Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. No engines, no libraries, except we did give you the option in the asset packer of using STB if you wanted to. We've got an if0 in there, so you do actually have the option in Handmade Hero's asset packer of using one library. Otherwise, you can extract the font from Windows, of course. But I feel like people probably would prefer to use the library because STB libraries are so darn good. And Windows is not that. It's the opposite of that. But yeah, in the mainline game, Handmade Heroes, no libraries still, no engines still. That's kind of just the rules. That's just the way it goes, people. And so that's where we're at. Right now, to be honest with you, I don't know exactly what we're going to do today, but I think that what we probably should be doing, as it's been a couple days off, what we probably should be doing is going through the font code now and figuring out how to do actual construction of sentences, paragraphs, that kind of thing with our font. Because all we really did with our font last week was show how to extract the font using either Sean Barrett's libraries or Windows directly. And that was just for asset packing, so all it did was just put that in our asset files. But our game really just loads them and uses them exactly like bitmaps. And right now, there's absolutely no data stored with those bitmaps, so there's no way for the game to actually reconstruct those into anything that would normally be considered a font. You can't construct even a basic word with them. Because we don't even know stuff like, you know, that the letter O is short and like rests on the bottom of the baseline, whereas the letter G like goes below it or something, right? So when we would actually put these, if we tried to put these characters together to make a string, we would end up with something that totally doesn't look like what the font was supposed to look like. So that's probably what we should do. I do have a bug, however. That's the other thing that I want to address that someone brought up on the forums, and I think they're absolutely correct. I introduced a bug kind of late in the asset processing system, and so I wonder if maybe what we should do instead, before we go back to the font thing, is just fix that bug, because it's a relatively important bug, and, you know, like I said before, if I can, I always like to fix a bug immediately upon knowing about it, and sometimes I can't really do that on Handmade Hero because we're right in the middle of something, and you know, it's hard for educational purposes if I'm just jumping around all the time totally randomly, so I try to keep myself a little more constrained, whereas in my real day-to-day work I would absolutely stop right there and go fix it and then come back to what I was doing. And so I feel like probably what we should do is fix the bug, because we do have the opportunity to do so. We already just had a few days off, so it's not like we're right in the middle of something. And the next thing that we were going to do with fonts was really to start you know, pushing sort of the metadata aspect of the fonts, like what goes in there to tell you how to reconstruct stuff. And so that's really different from the font glyph extraction anyways. So I think that's what I'd like to do. Today is definitely a coding day. So day 165, if you want to follow along at home with today's coding, you will want to unpack day 164's source code. If you have pre-ordered the game on handmadehero.org, that zip that you can download, actually there's two zips, the one for the old first 100 days and the one for the current block of 100 days. You want that current zip should have a day 164 source code in it that you can unpack into a directory, and that's what I'm starting with right now. So let me take a second to explain what the bug is, and you'll probably, if you were with me, if you watched when we implemented the asset loading and streaming system, you should be actually pretty familiar with the stuff that I'm about to say, because we actually talked about it already. Because the bug was one that I specifically, intentionally had put in protection for, and then for some reason, in that way that I guess when you're programming you do, or maybe it's just because when you're streaming programming, it's even more likely to happen. I suppose this could be deleted now too. I removed the protection that we had. And so now we don't have that protection, and it's a bug that's very unlikely to occur. So having removed the protection, we probably will never see the bug, except for maybe in some rare circumstance, and that's exactly the kind of bug that you don't want to have in your code, because you will never find it. You know, that is obviously a reason to take a look at it. So let me explain what it is. If you remember when I said let's go ahead and do our own memory management, you'll remember we had this acquire asset memory function. And what I did was, in the middle of implementing acquire asset memory, I decided that rather than doing this as a sequential step. I would do it whenever the asset actually needed to be acquired. We would free any memory that we needed to free. And so if you remember, that is happening in this actual loop. So if we can find space for the asset, we go ahead and use that space. But if we cannot find space for the asset, we start to free things, and we free things until we can. Now the problem with that is that when we go to free things, like we are doing here, that activity could easily free something that we were already depending on having this frame, which would lead to us drawing a bunch of garbage on the screen. Not necessarily a catastrophic thing to have happen, but certainly not a pleasant thing to have happen to our frame. Right? So the question is, how do we, how is that, how's that happening, and how do we fix it, right? Well, it's happening because we build up a list of assets. We build up a list of render instructions, right? That's our render group. It's this thing, right? We build up one of these that's all of the things that we need to render for a frame, and then we kick it off to our multiple render threads, which then do a bunch of rendering on it, and that's all fine, right? The problem is when we actually do that, it means that these bitmaps that are used in the render instructions can never be freed until after the rendering is completed. And in fact, we did some work to prevent that from happening with multi-threaded rendering. That is where our asset locking comes in and all that stuff. And so we kind of all knew about that. And what I did to protect against that is I made it so that assets could only be evicted at a very specific time, right? I had a thing called evict assets as necessary or something like that. And we would call that, and that's where we would do our eviction. And I specifically said why I was doing it that time. I was like, so that we don't free things that are currently in flight, like this. But then what did I do? When we implemented this function, I was like, oh, I'd rather do it here, and then I did it here. And that totally reintroduces the bug that I was trying to avoid. Now, assuming that we have enough memory so that we're never rendering close to our memory limit in terms of the number of things used on a frame, which is pretty much certain to be the case, we'll never actually hit this bug. And so that's kind of good. So in some sense, we could just leave it in there and cross our fingers, right? That's something we could do. But I don't know about that, right? I mean, it doesn't sound like a particularly robust thing to do, and I think it should raise the question, can we do something better? And so what I'm wondering is, do I now want to start, maybe looking, do I want to potentially look at doing something a little fancier? Is there something I could do that would actually allow me to mark assets definitively as being used or not used in some specific way? Right? And the reason that I was thinking about this was because I was like, I would like to be able to keep freeing stuff here. I think that's a more efficient way to do it so that we only actually free when we know we actually need to free stuff. That seems like a good idea. And furthermore, the other thing I was thinking of is in our asset system, this locked nonsense, it just complicates things, right? There's this notion that assets can be locked, and if assets can be locked, it means that they cannot be, evicted. Well, if we're going to have that complication, wouldn't it be nice to just have something that was a little bit more flexible and worked a little bit better, right? Because if we already have to have that for the background threads, is that locked thing is kind of a relatively crappy way of implementing that too, because it means that, if you remember, those assets can never be paged out, even if the background processes aren't using them at this time, right? Those assets get locked when the background tasks use them and never get unlocked, right? They have to stay in memory forever. And that's not nearly as efficient as it could be, especially if we end up having lots and lots of background art composition assets or something like this, right? So that's just, that's basically what we're dealing with. That was the thing that I had written down. And so I'm going to just brainstorm for a second. I'm just going to kind of talk about the problem a little bit and see if I can arrive at a solution that would solve both of those problems in a way that maybe I would feel a little bit more comfortable about going forward. So that's what we're going to try to do today. We will see if we can succeed. So here is day 165. and this is going to be like asset, or I should say in-flight asset protection. And in-flight asset protection, the word in-flight often is used in programming parlance to mean something that is being used in a system in a way that like matters to other systems, right? It's like if something's in flight, then it means that, like, you know, for example, with the bitmaps, if a bitmap's, I'm saying this bitmap's in flight, I mean that some system is currently in the process of using it. And if somebody else comes in there and mucks with it during that process, that could be very deleterious to this other system, right? So an in-flight asset is one that's like going through the process of being used, which may take a while. And so what we want to do is figure out a way of protecting our assets so that while they're being used in these different rendering scenarios, we don't evict them from the set of in-memory assets to replace them with some other asset, right, that might be used. And so what we'd like to do is figure out a way to do that, right? So if we think about the usage pattern for this, right, if we have an asset, we then have render groups. And there are multiple render groups in the system. These render groups use the asset, right? So we have a render group, for example, this might be a ground tile render group, and this might be an actual game frame, right? This might be a frame of the actual game, and they both might be using this asset. And what we know is they begin using the asset at some time, right, in their existence, and then when they're done, when the render group is completely committed and has finished, they no longer need the asset. So there's basically an interval, right? There's sort of a usage interval, right, that we can talk about in regards to when this asset becomes used and when it is released, right? So it's kind of got an acquire release sort of semantics to it, right? Like a reference counting sort of semantics to it, where you say, I'm using this thing now, and now I am not using this thing anymore, right? And so, yeah. So what we would like to know is if we were going to replace a given asset. Because remember, this is not garbage collection, right? This isn't saying that once an asset is no longer used anymore, we want to get rid of it. That's not true. When an asset's not used anymore, we typically keep it. We only want to get rid of the asset once we need space once we need space for a different asset, right? So what we're trying to do here is not so much keep track of when it's used to get rid of it. What we're trying to do is keep track of when it's used to prevent sort of our other sort of thing, which in some sense you could think of as the garbage collection, although it's not garbage. So it's virtual memory paging, basically, right? Our paging system from ever paging it out when it is actively in use. So obviously we could introduce literal acquire release semantics, right, if we wanted to. We could literally have acquire and release. We could have an integer on an asset that's like its usage count, right? And every time one of these render groups uses it, we increment the usage count. And every time one of these things, finishes using it, it decrements the usage count. Now, here's the problem with that approach, because that'd be relatively easy, right? It would have to be atomic, because these can happen for multiple threads. But we could use an atomic increment or an atomic decrement. We absolutely could use those. But there's a problem. We don't really know when we're done with them, right? So right now, what happens is we go through the render group and we do all the rendering. Acquiring is easy. We know exactly where that happens. But right now, we don't ever step through and figure out what all the things are we need to release. So in order to actually execute that release, in order to execute the decrement step to figure out if something's use count was 0, right? In order to increment the decrement step, we'd have to run through the render group's contents a second time, looking at all of the bitmaps in the render group and decrementing them. So it introduces this whole other big old nasty piece of code that has to go through again. I mean, it's not like it's that complicated, but it's totally extraneous, superfluous work that is there for no reason other than to release these bitmaps. And if that was the only alternative, I might say leave the bug in there. It's way more efficient to not do that. It's potentially a lot less error prone to not do that because we know the cost of our current bug is just we draw some garbage on the screen once in a while. And probably it will actually never happen if we have enough memory. We'll probably never actually have that happen because the chances of you evicting an asset you just used are extremely low. You're much more likely to evict an asset that was used like 2 frames ago and that hasn't been used in a frame or 2, right? That's what the least recently used thing eviction scheme does for us. So before I would introduce that complexity, which has a really bad failure case, right? The failure case there is the plus-plussing. If you don't symmetrically subtract from one of the plus-pluses, you would end up incrementing your assets without ever decrementing them properly, and you just end up with asset buildup until you get flooding the entire system with assets that can't be evicted, and then the game can't run anymore. Right? It wouldn't be able to load any new assets, so you'd just only be able to see parts of the world you already saw, and you wouldn't be able to see any new ones, right? So that's a problem. So I feel like that is not a good option. Now, what might be a more interesting option would be to use a sort of an ID sweep, right? Or I guess, I don't know if there's a good word for this. I feel like generation index might be the best way to describe it. But what you could imagine instead is, instead of talking about assets as having a increment or decrement involved in them, right? What we could do instead is have some notion of the render groups as being a series, and then using that series to lock our assets, right? So for example, let's say that every time we create a new render group, right, it gets an ID. And that ID is some kind of monotonically increasing thing, right? So the first render group gets 0, the next render group, right, gets 1, and so on. And these are all atomic, so I do an atomic increment on a number, and whatever I get back is my render group ID. So I know that even in a multi-threading scenario, no 2 render groups have the same number, right? Okay. So if we were to do that, then what we could do is every time we use an asset, instead of incrementing a usage count, what we could do is we could write in the generation index into the asset, right? So every time we write it into the asset, right? So if the if a render group goes and uses one, what it does is it writes it in there. And furthermore, we could do a scheme where we always keep the latest one, right? So basically, we read out of the thing, we read out unatomically. So we just read whatever's in there. We take our render group and we produce the maximum of those 2. And then we do an atomic compare exchange for the one we read out and ours. And that way, if someone else has come in and replaced it, right, we won't replace. We'll just sit in a little loop and try to replace it. But if it is, we'll replace it with the higher number, right? Something that always basically replaces with a higher number. And that would be pretty trivial to do. Okay. So we could try to do something like this. Now, if we did something like this, what that means is that now an asset has, basically a tag in the corner, right? It has a generation index. And what that index tells us is that until the render group with that number finishes, and all prior render groups as well, we cannot guarantee that the asset can be evicted. So wait until then and do it. So then all we need to do is we need to make sure that we can actually retire these render groups in a way that lets us know what generation index has actually completed, right? And that's actually not that hard to do. It's a little annoying, but it's not that hard to do and not super expensive. And so once we do that, we can then just compare our assets to the current renderer generation index, and assuming that the asset compares below it, we know that it could be evicted. If it compares equal to or above it, we know that it couldn't be, right? Something like this. And that would be one way of us knowing that we would never evict assets. That we... Excuse me. I'm tired today. It has been a sleepy programming day, I don't mind telling you. I was falling asleep at work. Anyway, so that is one thing we could do. Now, there's a little bit of wonkiness there in that we do have a problem where we kind of need to watch out for wrapping. Like when we get up to uint max, right, the maximum of a 32-bit integer, we have to be aware of overflow, right? We'd have to design it so that when we check the asset, we actually check for some kind of assigned distance between it and whatever this generation index is, so that we don't have the bug where when we wrap around, everything kind of freaks out, right? Because you know, if we are rendering at 60 frames a second, right? Just to give you some perspective here, at 60 frames a second, right? You know, if we were to take sort of that integer maximum, 1024, 1024, 1024, that's what an unsigned integer can hold. If that was our count, at 60 frames a second, right, it's going to be that many seconds. That's that many minutes. That's that many hours, right? All right. Maybe that's not quite right. Let's try that one more time. Like I said, pretty sleepy day. Maximum value, 60 frames a second, right? 60 seconds in a minute, 60 minutes in an hour, right? 24 hours in a day. And so, yeah. So, you know, rendering at 60 frames a second, that would be 2.2 years the game could run for without wrapping. Of course, it's generating ground chunks in the background, so figure, you know, at most 4 or 5 times out of frame. So, you know, I mean, 6 months. If you left the game running for 6 months, you might wrap. Just something to think about. So do we need to cover that? Okay, maybe we don't. I don't know. It depends how you feel about it, but I'm just saying that it's something to be sort of aware of. Is it likely to happen? No, most people aren't going to run the game for more than a couple days at a time at most. But, you know, it's worth at least thinking about, to say the least. So I don't know. That seems to me like the most likely thing to work. I don't know if I have any better ideas. It may just be because I'm sleepy. Maybe there's a better idea that I'm just not seeing that is there. But that seems kind of like the most likely thing. So the tricky part, if we were to implement this, is going to be something along the following lines. We have render groups, right, that are completing. They are completing multi-threaded. And as these render groups complete, they obviously have, you know, their numbers in them, right? 3, 5, 9 or something. And what's going to happen, you know, is 9 might complete first, right? And then 3, and then 5. So we certainly can't write, when a render group completes, if we wanted to know what the current number was of like the completion status, we certainly can't write 9, you know, to the like completed status area, because 3 is still happening. If 9 completes first, we can't write 9 because we got to wait for 3, right? And so what we really need is we need a number that's like the last known thing that was completed, which would be in this case like 2 or something, right? The last known thing completed would be like 2. And so if the thing that completes is not 1 after this thing, then we don't increment the number. So we look to see if the number is the next number, and if it is, then we bump it up, right? So once 3 completes, we're good. But now the problem is, right? And in fact, I probably should have done this in a more straightforward way that shows it a little bit clearer, the other problems that we're going to have. So let me do that. So let's say we have 3, 4, 5, right? 5 completes first. then 3, then 4, right? So we look at 5, and 2 is the current number. And we want this to monotonically increase as things complete. So 5 is completed. It looks at 2. It goes, I'm not going to ink that because it's not the next one. It looks at 3. It is. So it crosses it, goes to 3. Looks at 4. That's correct. It goes to 4. And now it will stay at 4 forever because 5 already completed a long time ago, right? So what we kind of need to do is we need to buffer these up, right? We need to store the fact that 5 completed, and we're just waiting around, we're just kind of waiting around for that to happen. So as soon as it hits 4, it goes, oh, and also, by the way, I already saw 5 being completed, so let's increment this thing, right? And that's a little tricky. Normally, you try to not have to do this, right? It's a little annoying. But yeah, what are you going to do? If we really want to have completely asynchronous stuff, you kind of got to do it. There's not a whole lot else that you can do. So yeah, so probably what we'd have to do is do some kind of buffering scheme. Normally what you do is you try to avoid this situation, and what you try to do is have just countables. So you just try to say like, oh, I issued 3 things and I need to know when they're all done. So you just have a counter, and when that counter hits 3, you know that these all finished, right? That's what you typically want to do. But in our case, we actually want to know more granularly because we want to be able to start freeing assets. So if 4 finishes, or if 3 finished first, we'd want to know that and start freeing those assets, right? So it doesn't, using a countable situation doesn't really help us in this case. So yeah. So that's going to be a little bit janky. That code is not going to be fabulous. I'm not a fan of that, but I can't think of anything better, again, off the top of my head. So let's take a quick look at our current situation and see how likely it is for us to, to be able to implement this. All right, and so pretty much get bitmap and get sound are what we're talking about here, right? So when we come in here to get bitmap or to get sound, what we would want to do is we would want to do that sort of asset lock right here, right? We want to be able to say now is the time to do the increment, and off we go. So I'm not sure exactly how you would want to do that. I'll have to think about that because we need to make sure that the thing is loaded. And so I'm wondering if we need something a little bit fancier there. So here's what I'm thinking. Here's what I'm thinking we would do, right? So let's say we went into Handmade asset here, right? And we've got this stuff. We could get rid of locking because that's not going to happen anymore, right? So we have asset state. We've got unloaded, queued, and loaded, right? And then we would, if we didn't care about wrapping, we would then have like our generation index. Or generation 0, right? Something like this. So if we wanted to do that, then what we could do is we could say, all right, get the thing out, something like this. Get the state of this asset, right? And this is an asset state. Get the state of the asset, assuming that the asset is greater than asset loaded, then we're going to rewrite it with whatever our generation ID is, right? So it'd just be like assets, generation ID. We'd assert probably that is always greater than equal to asset state loaded. And we'd say, okay, this would be a compare exchange, right? Which I forget what we ended up calling, but we'll go look it up. This would be a compare exchange. And what we do is we'd say, we want to see whatever the state was. Assuming we do, we want to replace it with this, right? That's what we would want to do. And so then we would do, we'd make an assumption here. We'd probably do something like this. While that state is correct. In fact, I guess we would maybe do it possibly even just like this. Again, inside, this is sort of the standard multi-threading pattern where you just kind of have to try things, right? We get the state, assuming that it's possible. We try to do the compare exchange. Otherwise, we break out of the loop and it's done, like we didn't find anything, right? We do the compare exchange. And assuming that we are able to do that generation ID swap, then we go ahead and move the header to the front, right? Now, part of the problem with that, again, is this move header to front. What would be nice about this, too, is if we could sort of get some notion. Because now, the other thing about this is that generation ID also tells us how recently used the asset was, right? So it's like the move header to front thing doesn't super need to happen, right? It just doesn't, it's not something that really needs to happen. So I don't know. And furthermore, multi-threaded wise, we don't really want multiple people hitting this move header to the front. So yeah. It's a bit tricky. It's a bit tricky. But anyway, we would do this compare exchange, and then assuming that we were able to do the compare exchange, we would then do the sort of asset header bitmap thing, and off we would go. So I guess that would basically be it, except for the problem of now how do we keep our assets sort of sifted in a way, sorted in a way that's actually useful to us, because when we do that sort of compare exchange, that change, it's kind of a little bit annoying. Like, what would we we want to be able to do something like one of those asset reorganizations, but that's pretty hard to do multi-threaded, because if you do it multi-threaded, you're going to have to take some kind of a lock. W-link lists are like kind of annoying. I mean, you don't have to take a lock per se, but if you did it lock-free, it's a huge nightmare. It's not a good. W-link lists are not fantastic in terms of lock-free sorts of stuff. That's not fun. I say. But that's basically what I would want to do, right? And it seems like there should be something fairly clever that we could do here, because once we have that generation ID, like I was saying, that generation ID actually also tells us how old this particular asset is, so it would let us know which ones we should free in addition to that. It's just we would need some way of more quickly accessing, one of them. And in order to quickly access them, we're going to need to keep them sorted in some way, like with a heap or something. And in order to do that, we have the problem again of the multi-threaded heap, that's just kind of ugly. And you could take a lock, but then it's like, okay, if I take a lock, then everybody who's trying to do rendering stalls up on get bitmap. So it would be kind of nice if we could figure out a way to not have to do that, right? But I'm not thinking of it. I am not at the moment thinking of that. And so, there's things we could do, right? We could have it so that only the main thread actually does the move to front. And that would solve that problem. The problem is that then means that, assets might get shoved to the back that were just being used, that are actually frequently being used, but just for ground chunks and never for anything else, which is highly likely, right? So this is a puzzler. This is a nasty one. This is a nasty one. I'm not sure. I'm not sure what to do about it. I would like something cleverer here than anything that I'm thinking of. This is where it would be helpful to have another programmer. I would like to chat about this. But you don't always have another programmer. It's a bummer. It's true. But you can see what the problem is, right? So what I've got, what we sort of were saying is that, okay, we've got, something. In this case, it happens to be a doubly linked list. But we've got a doubly linked list of assets. So here's asset A, here's asset B, here's asset C, right? And we're parachuting in here and we're gonna use this asset. And what we were saying is, well, this thing is kept in sorted order right now, so that the thing that was used the most recently gets moved to the front, right? So that we always know how to find the most and recently used elements. But if there's two threads that could be coming in here and visiting this guy, you really don't want this thread to be in the middle of updating these pointers when this thread then goes and tries to update them as well, because you'll just end up with garbage and it could be really bad, right? So this is a frowny face, right? And what we need is some way of figuring out, how to get the frowny face out of there. We need a way of reliably keeping our usage thing set up, sorted, without the restriction that only one thread at a time could access it, right? We'd like as many threads as we want to be able to access it, right? So I guess one thing we could do is just queue those, right? Which is kind of absurd, but we could do that, right? We could just introduce some scratch space, and every time we touch an asset, we write it into a queue, right? Just into not even a queue, like a stack, right? Well, it probably would be, actually would be a FIFO, right? So we just write in there, and we just write in every time we use something, right? You'd write it in there. And then what you do is you'd have just one thread come through and do these things in order so that you know that it would do all the moves to fronts in particular order, right? I don't love it. Do I have a better suggestion yet? No. But that's one thing you can do, right? Because it's easy to turn that into such a thing. What am I not thinking of? What else could I try? I guess so of the ways that we're looking through the assets themselves, I feel like there's nothing particularly smart to be done there. I guess we could try to see if a lock-free heap was too difficult to do, right? Like, how much complexity and how difficult do we think it would be to do a lock-free heap? If the answer is not too bad, then we could turn this into a heap sort of a structure, in which case we could then update it for multiple threads without having to worry too much about it, right? And I mean, it's not out of the question that could happen. It's not entirely implausible. I guess there's one more thing that'd be kind of, oh, wait. Huh. Well, I did just have an odd idea. So humor me for a second, and let's think about this. Well, no, you know, this is going to be the same problem. I'll talk it through still, just so that I say what I was thinking, but then I realized the problem is I won't be able to figure out how to remove the links. So it doesn't actually help, I don't think. But anyway, so you could imagine if I were to take the render groups themselves, right? So like render groups B, C, D, right? These sort of things. If I were to have each render group, and in those render groups, I was to actually just link off the assets that were used, right? In those render groups. Then that would effectively give me my generation index thing, right? So, you know, each one of these guys would have a generation index in them. When you go to use an asset, if the asset has a lower generation index currently than the one that you are, you move him into your list, right? And then you tag him with the new asset index. And that way, you know that he's always in the linked list of, you know, the render groups of the Go. And then when render groups get retired, you basically take whatever's in their list and move it to whatever the next render group in the sequence is. You give the list to them. And then you know whenever you want to free something, you just use whatever's on the front of that list. What I realized is, as I was saying that, it doesn't actually help at all, because in order to remove an asset from one of these things, I was thinking just in terms of adding, and a singly linked list is trivial to do. Addition to a singly linked list is trivial to do lock-free. It's just the exchange. It's just a pointer exchange. But that doesn't actually help, because in order to get one of these moved, to move it, you would need it to be doubly linked again, right? And once we're back to doubly linked, then forget it. It's the same as what we've got now, right? So the minimum thing is still too much. It's still too much of a deal. So I guess another thing we could do is we could just sort all of these guys separately. Because I guess, now that I think about it, sorting is doesn't really have to be done in a multi-threaded sense, right? Like, if the sort went wrong, that's probably okay. Maybe it's not okay. So what I'm thinking is, let's say we've got all our assets in a table, right? And we've got their numbers, right? Here's their generation indices. And we want to just sort these guys, right? So like, here's the generation index, here's the number. And I wanted to sort these guys. If these numbers are changing during the sort, then the worst thing that would happen, I was thinking, was that the sort just doesn't quite sort quite right. Right? I mean, that's all that happens. It's not really the end of the world, because we're just using it to figure out what asset we probably should get rid of. But the problem I was thinking is it might mean that the sort wouldn't terminate, I think. And that would be significantly worse. Oh man, I am so tired. I tell you, this is not the kind of problem that you want to tackle when you're tired. But I got 12 minutes left to the end of the stream, so even though my brain is completely shot, might as well look at it for 12 more minutes. The worst that can happen is you don't think of anything. So yeah, so I guess what I'm thinking of here is like, right, if we were to do a sort, then could we do a sort where we knew that we would never get into a condition where the sort would never terminate, like where people kept changing these values on other threads while the sort was happening? Is there a way we could guarantee that wouldn't be a problem? And it feels to me like the answer is yes, because if we pick something like a merge sort or something like that, which doesn't loop per se, it more just like divides and conquers, then if one of those divide and conquer steps is wrong because the generation index that gets used is the old one instead of the new one, presumably that's okay. It just means that your sort ends up being wrong at the end. And maybe we don't care if the sort is wrong at the end. Furthermore, it seems like we could make it, we might be able to sort of design the sort a little bit around that notion and make it so that just because the sort is wrong, it doesn't actually matter too much. Like that we still get a relatively correct result, right? And I suppose yet another thing we could do is we could just build this sort out of band. Well, that seems like it's too expensive. I mean, you got to figure, you know, we may have like 5,000 assets or something. And so what we would like to do is we would like to sort these guys. We'd like to keep these guys sorted if we could, because that number is going to be real big. So we really want this to be like a heap. I don't know, man. I don't know. Off the top of my head, I don't know how bad a multi-threaded heap is. I don't know how nasty that is. Let's see. Let's see how bad it looks. Just, you know, just do that little spot check. Like, look at the paper and go, should I be terrified or shouldn't I be? Right? Let's see. Let's see. The algorithm is based on a sequential skipless data structure, randomized, and has a randomization has a probabilistic time complexity of O log n. Randomized is not something I typically like to hear all that much, but you know, what are you going to do? So that's not too bad, right? I mean, I'm not reading this paper because it's not really something you can do on stream, but you know, that's not awful, right? That's not too bad. And you know, it's got delete, right? It's got insert. You know, does that look great? No, you know, there's a lot of complexity in there, right? A lot of things that could go wrong. But if it was the only thing, that wouldn't, you know, wouldn't kill me. I wouldn't be like, oh my God, no. Maybe we'd write a little bit of test code for it, right? So yeah, we could do that. But the other question then is like, well, you know, also we don't really know very much about how that thing behaves, so would it actually just be better to just take a lock, quickly do the move, and then release the lock? Because, you know, uncontended locks are mostly free, and so it's not like we would pay very much most of the time. It would, because most of the time both processors would certainly not be taking the lock at the same time. So it starts to kind of seem like, you know, if you looked at something like that, that maybe you do just want to take that lock. You want to like do the lock, do the operation, and come back. I don't know. I really don't. But, you know, what would that look like if we were going to do that? Probably something like this, right? We'd say, okay, there's like, you know, asset state operating or something like this. And what we would do here is we'd say, okay, we're going to do a compare exchange. Assuming that the compare exchange succeeds, we do our operation, and then we write in. Actually, I guess we want complete previous writes before future writes. We do our little operation, and then we would write out the state to be something else. So our asset state would turn into something else. Our asset state would become whatever our generation index is, right? So we do some kind of compare exchange where we compare exchange in some value that was like the operating value, right? Yeah. In fact, we might even do that. Well, yeah, I don't know exactly what we would do. We'll think about that in a second. Probably, Man, this is really hard to say. But yeah, what we would do here is we'd go, all right, we need to operate on this and we want to be the only person who's operating on it, right? So we're already in a loop because we know that we're basically going to always do our operation. There's no way we won't do our operation. We just have to wait to make sure that no other threads are in here. So it's basically just air traffic control, right? So we need to do our compare exchange. Here's our exchange, right? Here we go. There we go. Atomic compare exchange UN32. We need to take our asset state and we actually need to modify it, right? We need to modify it by passing in whatever we want it to be, which would be the new generation ID for the, I guess we probably actually want to pass that in here. It's probably not quite that, right? So it's something that we're actually going to be tracking now where the render group has to give notice, essentially, as to what it's going to actually do here. So this would be a value that would probably get put in here. We do the atomic converter exchange. We'd say we want to set it to our generation ID, and what we expected it to be, sorry, that's not true yet. We want to set it to that operating value, basically that runway clearing value, right? And what we expect it to be is whatever it was before, right? And so in order for us to even attempt this, we want to make sure that state is greater than or equal to asset loaded, and state is, I guess in here, right? If state is not equal to asset state operating, then we'd do it, right? And what that means too is we really wouldn't have to worry about sort of the thing I was saying where we just all do it in one step. If we were going to take a lock of that nature, you wouldn't have to do this anymore. Inside the asset, you would just probably have the generation ID, right? Or you could also do it inside the header here, right? In fact, that's the better place to put it for certain, because then you're not using space in the asset, right? So yeah. So in this case, and you know what, really this asset state thing probably could be fussed with a little bit, because we also have the fact that now we point to a memory header. If that memory header is 0, we know you are unloaded. So we probably could actually streamline this a little bit. In fact, I'll put a little to-do here. To-do, Casey, streamline this by using header pointer as an indicator of unloaded status. But yeah, so assuming that we were going to do that, we would do that atomic compare and exchange to make sure that we could move it to an operating state, and then assume that we could. Again, now what we could do here is just say we assume that it has to be equal to loading, right? Loaded is the only time that you get to use this thing, because if it's not loaded, obviously you can't use it. And so then what we would do here is say, oh, okay, if state is not equal to asset state operating, then you break. So in other words, if it's loaded, we will try to do our work on it. If it's not loaded, then just double check to make sure that it's not just momentarily blocked by somebody else who's trying to do stuff with it. If it is, then just go ahead and loop again and try again. But on the off chance that that is the case, loop again. Otherwise, it's like either unloaded or queued, which means we can't use it right now. So just flub it, forget it. It's not going to happen, right? So we go ahead and say asset state loaded. We do generation ID. We don't need to check that anymore. So then we come in here, we set it to operating ourselves, and we want to make sure that it actually does what we think it does, which is that it's, again, going to kind of be that sort of thing, right? In fact, we know that it's always asset state loaded, so we could almost just say, we could even just do it this way and say, okay, we know that this always has to be asset state loaded, so it had always better be asset state loaded. When we then come in here and do our little monkey business, we then just reset the state back to asset state loaded when we are done with it. And now we can do whatever we want because we know that nobody else will try to do this, right? So that's fine. So it's not the best thing in the world. Is it fabulous? No. But if we are doing it that way, we avoid any possibility of stepping on our own toes here with move header to front, right? So then at that point, yeah, it's pretty easy to update the generation ID because we know that nobody else can update the generation ID because we just took a lock, which means that all we have to do with the generation ID is make sure that if our generation ID is higher than its generation ID, that we would set it, right? And so what we would want to do here is say if the asset header generation ID is less than our generation ID, then we would want to reset that, right? So, like so. I don't know, is that weird bug where, yeah, it is. For some reason, sometimes Emacs thinks when you type this that you're starting a template declaration and it won't get out of it. And you have to go delete it and put it back, which is why these were just momentarily indented. A weird bug. So yeah, so that would get us out of the locking business. We could also get out of the get state business and the state masking business and all that nonsense, which would be nice, to say the least. And then we would just sort of look at the asset state a little more directly. And yeah, and that would all be good. So we would need to introduce that generation ID thing. Other than that, I think it's all good. In this case, I suppose we want to look, we don't want to reread this really, so I suppose we do kind of want this to be read out, just so we can do the test on the same value, right? Like so. And off we go. Right? And that would preserve the state as well. I don't really know that we care about that, but there we go. So that is all she wrote. I guess we could also just make that a U32. I don't think there's anything else particularly much to it. It would be nice to share this piece of code so that it doesn't have to be duplicated, since it is going to get relatively complex in here, as you can see. It would be nice to basically, do this thing. They're exactly the same piece of code, even down to the part where if you take a look, both the bitmap and the sound are actually in the exact same place. So these things do literally exactly the same thing. So what we would want to do here is we'd want to probably just do a thing where we return the asset header, right? We'd want to do a thing where we do like, asset memory header, basically get asset. And we would want this thing to just do, an asset index, right? Something like that. We could get rid of the must be locked nonsense. And then this thing would just do its thing. Right? It would just say like, all right, I've got an asset memory header here. And instead of all the stuff, I'm just going to use just the asset memory header because there's no reason that I couldn't do that. I go through doing everything that way, and then when I get down to the place where I would actually snap that result, instead of trying to do the bitmap part of it, I just grab the header so that I'll return that. And then these guys can all just do something really straightforward, such as asset memory header, right, equals get asset, assets, id.value, if header, right, or I don't even have to do that. You can really just do this. Load a bitmap result is like header, header bitmap, otherwise nothing. And that'd be like it, right? And then loaded sound would do exactly the same thing. Right? So it's just a question of getting the types right. For C's type checking there, but otherwise exactly the same code. It's even returning the exact same pointer because these two would be at the exact same address inside this thing 99% of the time if there wasn't some kind of alignment change. But anyway, so that is mostly that. I think if barring the generation ID stuff, that's totally fine, right? Right? Am I right? I don't know if I'm right. Hopefully I'm right. Get rid of all this locking stuff. Final states equals asset loaded. I'm just gonna blow. I never liked this locked stuff. It was such a hack. Did not like it, and I don't like it now. Didn't like it then, don't like it now. So that's good. That's all fine. And so now all we really need to address is sort of that generation ID stuff, right? And so the generation ID stuff is the part that I talked about today. And what we can really do at the moment, right, is we could start to try and get this code working by just going like, all right, forget about it. Like nobody cares. Let's try to make the rest of the code work first. So we'll just say, okay, nuke must be locked. That's gone. Goodbye. Recompile. Function does not take 3. That is correct. Assets should be locked. It needs to go away as well. Assets should be locked. Let's fix all this nonsense. Assets should be locked. Assets should be locked. Doop-de-doo. Function does not take 2 arguments. And so then we just have to take our load bitmap, which it looks like must have gotten spec'd here. Yeah, there it is. And get rid of those lock calls. There we go. So yeah, not quite there yet, right? But working to some degree. And I don't know if the code works at all. Code does not work at all. So that's fine. Oh, right. Probably want to exit that for loop at some point. Forgot about that little that little detail. We need to actually exit in the case where we worked, right? Can't keep trying forever. But yeah. So, you know, working, so that's good. We didn't break anything. But we haven't yet fixed the bug, because the bug is that we still need to implement that generation ID. So I think, you know, I feel like I talked through it reasonably well, to the point where I'm relatively happy that, you know, taking a lock here isn't a huge deal, because it's not a very hard lock. It's a forward progress style of lock. This function, this will effectively be free 99% of the time, because all it's going to do is actually do that compare exchange and be done. And people aren't probably going to hit this almost ever, right? So I think that should probably be okay. These are just, there's like almost nothing happening. It's only this move header to front that's ever happening there. And so I feel like that's probably fine. And the other thing that we can do is move header to front if we want to kind of clean this up a little bit. If I take a look at what that's actually doing, you know, is that doing much? And it's not, right? It's pretty straightforward. So I think that it would only be like a few cycles in there, hopefully, you know, less than 1,000 cycles or something that would ever be hitting, even in the worst case, hopefully. I don't know. That might not be true. We'd have to take a look at it a little more cleanly. But so that would do it, and that would get our generation ID stuff spec'd properly, so that then we could just use the generation ID as a guard against eviction, which would finish sort of getting rid of that bug and also getting us out of the business of locking our assets, which is kind of a double win in my opinion, because we fix the bug and then we get rid of this stupid thing that was really janky in there, and I think that's a plus. So let's go ahead and go to the Q&A. Like I said, I'm very sleepy today, so I apologize if my answers are kind of just random. But if you have questions about the sleepy stuff that I was doing today, you are welcome to ask me them now. Put Q colon in front of it, and I will answer the question. Oh, I did not get enough sleep last night. Sherlock93. Hey, Casey, can you do a 2-minute recap of everything done today? Yeah, I mean, basically what I had to do today was I wanted to look at some code that wasn't right, It was kind of a little busted, and basically what I had done is I had moved a function to a location that would make it, you know, that would introduce a bug that I didn't have before I'd moved that function. What it was we were evicting the assets inside our function that allocates new memory for the assets. And that function was called anytime you might try to go and load an asset, right? And since we might be trying to load assets in the middle of doing rendering and stuff, that means that we'd end up in a situation where we could evict an asset we were depending on being there in a future render kickoff, right? Because we like build up all the render things we want to do, and those point to the bitmaps that they need, and then we kick it off. If those bitmaps get evicted in the middle of the render before it has a chance to finish, we just draw a bunch of garbage to the screen, and nobody likes that, right? That's ugly and unprofessional. So in order to fix that, what I wanted to do was come up with some scheme where I could mark when things were used. And so what I'm going to do is I'm going to use this generation ID to do that. But while we were doing that, I also wanted to fix the locking concept, which is what we were previously doing to make sure that a thread that was using rendered assets didn't have to worry about the fact they might get evicted by the main thread. But it was always a little janky because the way that worked is it would just keep assets loaded forever that the background threads used. And so that was kind of nasty and stupid. So we also fixed that. But in order to fix those, what I had to do was consider how the locking profile would work for these things. So when you go to get an asset, there's things that we need to do. And those things can really only be done from one thread at a time. So what I did was I said, all right, what I'm going to do is I'm going to try to take an optimistic lock by setting the state field to this asset operating value. If it succeeds, it'll do the stuff. If it fails, it'll just try again. And it'll keep retrying forever. Because I know that only so many threads are ever going to try this, and they'll all complete eventually, right? I mean, technically, you could get in some situation if you had some code where they were all just calling this repeatedly and doing nothing else. Maybe that wouldn't happen, but really that's not super possible. So. How often do you actually implement something from a paper? Not that often. Not that often these days. I think it largely depends on the discipline in which you're programming. Like, if you're doing graphics work, like 3D graphics work, you tend to read a lot of papers because there's just a lot of stuff and a lot of people doing research on a lot of areas of it. And so the chances that you're going to find useful information in a paper, and you may not implement the paper exactly, but you'll get good information from the paper, right? In a 2D game, does it happen that often? Not really, right? Because there's not that many people doing research on 2D games. And so it's a little harder. What would be the worst case scenario if you had multiple threads trying to remove an asset? Couldn't you just wait till no thread was trying to remove the asset? Well, that is kind of what we're doing, right? I mean, I'm not sure what you mean by trying to remove the asset, because removing the asset is not really the problem. It's using the asset that's the problem. And what we were trying to do is implement a scheme where we know definitively that nobody is going to use that asset. Pseudonym 73, one way to avoid the lock is to split the least recently used list into two parts. Keep the most recent 25% of it in one partition and the least recent in 75% in another. Only move an asset to the head of the list if it's in the least recent part. How does that help avoid the lock, though? Don't you still have to take the lock? Because how are you keeping it partitioned into those two pieces? In order to keep it partitioned into the two pieces, you have to take the lock at some point at the boundary, right? So if I understand correctly, says James Widman, our problem is that least recently used in this context means Least recently stopped being used in all threads, and we can't really know that for certain without having some form of inter-thread communication. Is that correct? Yes. I mean, I don't know that I would have necessarily said it the way you said it, but I don't think that's an incorrect way of saying it. What I would say is that we have a notion of least recently used. That notion is just this move header to front. So that linked list that we're keeping is always in perfectly sorted order, right? If we just wanted to be bros about it, right? And you wanted to be like, you know, bro, I just benched 375 at the gym, yo, right? And it's like, you know, meathead protein powder action, right? If you're just going to go that route with it, then you would just say, that's fine. We know the list is in sorted order. We know we will have enough memory in the system so that we will never be counting on using an asset in the back, you know, 50% of the LRU list. So it's always fine to free what's in the back of that list, right? We could do that, right? Now, I would argue that even if we did that, we should still have introduced this atomic compare exchange, because what we want to do when we do that is we want to make sure that if you're going to go delete an asset, you're not deleting one that another thread was just about to move to front, right? Because you could have a race condition there. So you still want this, I think. But in general, this would totally solve the problem. The code that we just wrote would be like fine. I mean, barring the fact that we should probably step through it and look for bugs and stuff because I just typed it in. But, you know, assuming that it was working the way that I wanted it to work and debugged, then yes. But the problem with it is if we wanted to guard against the possibility of evicting an asset that was still being used because we're in some really tight memory pressure scenario or who knows what's going on, where there's hardly any memory for assets or something, and so it's possible to actually be using everything in the LR in the whole bank at once, and so you shouldn't even free the last guy in the list. Or if you have a situation where one thread just took a really long time and somehow its stuff is at the end of the list even though it was like least recently used, you know, because we're only doing it on the move to on the part where you actually start using it, not on the part where you end using it, right? Then we don't have protection against that. And so generation ID was just a way of adding that insurance. So that's, you know, my description of it. I think your description of it is fine. It sounds correct to me as well. Pseudium73, you don't take the lock on hot assets most of the time. Well, we don't take the lock on assets at most of the time anyway, right? Because there's no lock to take, really. Like, all you're doing is doing one atomic comparing exchange, right? Doing, like, you know, 10 mobs or something, and then setting the state. So the chances that that lock ever actually executes, like meaning that someone actually gets locked out by it, which is the only time it costs you anything, is, I feel like, going to be really low. But I could be wrong about that. Not to mention the fact that the assets used by the background threads are often not the same assets that are used by the foreground threads, so I feel like that lock is just never contended. Probably ever. Like, it's probably like, you know, once in a blue moon kind of thing, right? I haven't seen you drink any milk in this stream. Is that where you're tired? It could be. It could very well be. Easy Fool says, you can avoid the generation ID gap checking list by keeping min, max, CNT render group done IDs and freeing all assets max when CNT equals max minus min, then reset min equals max. I'm sorry, I don't know what you're talking about. But I don't think that would help us, whatever it is. Because why would keeping the minimum and the maximum help you? And first of all, the problem is, how do you even know what the minimum is? That's the whole problem. All you ever need is the minimum, right? I mean, the only thing you need to know is the minimum, and then you can do everything perfectly. The problem is, how do you know what the minimum is? The whole reason you need to keep the checking list is so that you know what the actual minimum is, right? So keeping more stuff doesn't really help you do that unless I'm missing what you're trying to suggest. And also, like I said, we're not trying to free the assets. All we're trying to do is prevent the assets from being freed. So if someone who looks at the LRU list goes, I need to free some asset space now, we just need a way of saying, check the generation ID and go, no, wait, don't free that. Right? I ain't seeing no more Q colons. Easy fool. You know the min render group that completed, but like you mentioned at the start, if they complete out of order, the min isn't what? Sorry, I'm not sure if it like cut off that or something. I don't know. All I got was, you know the min render group that completed, but like you mentioned at the start, if they complete out of order, the min isn't, and then I don't see anything else. Oh, isn't correct when a gap occurs, so you need to track the interval and jump ahead when it fills. But maybe I'm just misunderstanding the situation. No, that's correct. That's what I'm saying. That's why you need to keep the list. Because the only way to like fill up cross the gap is you need to know if all of the numbers in the gap actually happened, right? And so in the worst case scenario, you need to know exactly which ones did that. Because otherwise you have no idea, right? Like the thing that you're talking about would just be like an optimization to jump ahead in the case where it happened that they all completed. But you don't care about that case very much. You care about knowing how far to go in the normal case where there's just a couple missing, right? How far forward can you go? I'm at the day 19 video improving audio sync, and in order to get time begin period to work, I had to call it twice. Do you have any idea why? Do I have any idea why? Not off the top of my head. I don't know. I'm not sure why you would have to call that twice. Are you sure that's actually what happened? Are you sure that you didn't just think that that's what happened and maybe there was some other thing that made it appear like that was happening? I mean, it's totally possible that that happened, but that is not something I would have a guess about off the top of my head. Any update on what algorithms you use to do laundry these days? I just keep them in laundry baskets like I did when the thing I described on the podcast you're talking about is totally what I use. I haven't really upgraded it since. All right, that it for Q's. It's good because I'm sleepy. Easy fool. Never mind. My keyboard and my internet seems to be dying. I'll wait till. Uh-oh. Yikes. That's two bad things to have die on you at the same time. Sharlock93, I think we should do a detour and make a simple ray tracer. We should just, yeah, like eventually we'll do like a Handmade Hero that's just all ray traced. Clearly. Of course, I don't know who's going to make all the 3D art assets that we would need if you wanted to do that, but a ray traced Handmade Hero would be awesome. All right, let's wind it down because I am too sleepy to do any coding anyway. I was too sleepy to do the coding I actually did on the stream. Let's be honest about it. That's just the way it was. Probably was all really obvious stuff that I just like was not thinking of anyway. I made it harder than it had to be. Anyway, ladies and gentlemen, thank you for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with the source code, and you can download it every night after I finish programming. I upload our latest changes. We also have forums where you can go to ask questions, get an annotated episode guide, ports to Mac and Linux, all sorts of good things that the community helpfully maintains for you out of the goodness of their heart. We also have a Patreon page you can subscribe to help support the video series, and a tweet bot that tweets the schedule at you, so if you want to know when the stream's going to be live, that's the place to go. I am in the middle right now of testing and like getting the Unixness happening properly to have GitHub authorizations occur. So hopefully in the not too distant future, you will be able to start getting Handmade Hero from GitHub if you have pre-ordered the game. So stay tuned for that. I will be explaining how to do it as soon as I am confident that the system is working reliably enough to have anyone actually try it. Yeah. So until then, tomorrow I will be back here at 8 p.m. Pacific Daylight Time. Hopefully I will be more awake than I was this evening for these late night streams. And I hope to see you there. Until then, take it easy, everyone, and I will see you guys on the internet.